Okay. So we're here on the Quanta FIB. So this is the gallium FIB. And I got Toby here. Toby's the driver. So I'm just going to be kind of, commentating a little bit left and right. But we're going to go through kind of like we're going to just start from scratch, and we're going to do a FIB lift out. This is a sample of silicon that has a coating on the surface. I'm not really sure what coating it is right now. I don't think it's metallic. I think it's some type of ceramic or something like that. But Toby's going to go ahead and start and tell you everything he's doing all along the way. All right, go ahead, Toby.
So first thing we want to do is look at the user interface, and it's split into 4 different quadrants. We're going to use the top left quadrant here, and we're going to look at the electron beam. Then we'll use the top right quadrant, and that's going to be our ion beam. What we also care about is the camera in the bottom left quadrant, number 4. The bottom right quadrant. That's going to be so we can see how our stage moves up and down, and we also got to make sure that we don't crash any of our needles into our sample. First thing we want to do is we want to wake up our system. And then if you notice, the top left quadrant has a blue bar. That means I'm active on the electron beam. So if I click to the quadrant 2, the top right, then now I'm active on the ion beam. So right now what we're doing is we're warming up our gallium, and we're waking up our system, and we're waiting for this to go get green from red. So right now it's not on, but it's turning on. While we wait for it to turn on, what we'll do is we'll go back to our electron beam, our top left quadrant. And right now our scan is paused, so we're going to unpause our scan. And then you should see a change in contrast, and our valve opened up, so now we have SEM scanning right now. So what I'll do is I'll go decrease our magnification, so we're at 25x, and then we'll go find an area of interest. So we'll go to this area of interest. And what we need to do is change our contrast, change our brightness, and we'll change our focus until our area of interest comes into focus, which is somewhere around here. And I don't really need to go too high of a magnification. I'm at about 3000x. And then what I'll do is I'll link the stage. So this links our focus, our working distance, to the Z height of our stage. So what we want to do is we want to bring our sample up to 10 millimeter working distance. So we're going to raise the stage up to 10 millimeters. So what we can do is we'll change our Z to 10. And it should raise our stage. And in quadrant 4, you'll notice our sample moved up. And our working distance also changed to 10 millimeters. If we did not link the stage, then it's possible when we type in 10 millimeters, it'll go to a different place on the stage. So it's really important to make sure that you focus your sample and then link the stage so that the stage length is equal, the stage Z height is equal to the working distance. So then we'll go find another area of interest, and then I'm going to focus on this object that is not really our area of interest, but it helps us figure out if we're at the right Z eccentric height. So then what we want to do is go to our stage navigation tab, and we want to tilt just a little bit. So we'll tilt to 20 degrees. So what I need to do is I need to remember that object that I was looking at before, and then I need to raise the stage.
So Toby's now going physically over to the front of the instrument, and he's adjusting the Z knob to bring that up. So he's turning this clockwise. And the reason we have to be at eccentric is twofold. One, all the deposition needles are basically set to be at a certain height when you're at this eccentric. So when I stick that needle in, if I'm at eccentric, it's always going to be at, I believe in this case, it's 600 microns above the surface. So all the deposition is calibrated to that height. The other thing is if you're not at the eccentric position, you might actually be higher and you might ram into some of the needles that we have. And that would be a bad thing because it takes a while to get them realigned.
If you notice, as I tilt to a higher tilt, which is right now 40 degrees, our area of interest, our object that I'm kind of concentrating on is almost in the same spot.
So now he's adjusting the Z knob on the front of the instrument again.
And then I'll go back down to 0 degrees, and it should be roughly around the same spot. And we'll tilt to our 52 degrees. And if you recall during Roberto's presentation, the ion beam is at a 52-degree angle with respect to the electron column. So what we're doing is we're actually tilting so that we're now normal to the ion column. So then what I need to do is I need to go to our ion column page, or ion column quadrant, which is the top right. And if you notice, it's blue on that bar. Then we'll go back to the beam control page, and then notice it's now green. The next thing I want to do is we can leave the kV at 30 kV, and we need to go to a low beam current. If you remember, Roberto said during the lecture that anytime you have the ion column on and scanning, then you're removing material. So we're just going to choose a low beam current so we're not removing as much material. So I'll go to 30 picoamps, which is our imaging current. If I unpause the ion beam, I can now change the contrast and brightness. And then I can change the focus a little bit. And then we'll see that same object. That same object should be in the same plane now. So anytime I use the ion beam, I cannot use the electron beam. Anytime I use the electron beam, I cannot use the ion beam. So I have to always make sure one is paused and one is unpaused. So as long as we still have both areas of interest, and the electron beam and ion beam, then we should be all set, because this is the place that we're going to place a protective cap on. If you recall, we're always removing material using the ion beam, so we want to place, our first step is to place a protective cap using the electron beam. So then we'll go to our patterning page, and then we need to draw.
And check to see if I saved it under let's see if it's importable. Go to File, Import.
File, Import.
Patterns. Go up one. Go to silicon. Gonna do platinum E. Yeah. Okay. So you can either draw the pattern, or I've taken the time to go ahead and save these patterns for you, so you can import it. So that's the right size. It also gives you the right application file. The only thing you have to do is make sure you have the right current and voltage. So this is set up for 2 kV, and even though it says 5 kV in the application file, it's actually better to do it at 2 kV and to do it at 8 nanoamps. So to get up to 8 nanoamps, we have to go to the, yeah, that one. That's the flying saucer. The other one was the smiley face.
Yep.
So yeah, F9 is an automatic brightness and contrast, and lately I've been showing people how to use that because it actually seems to work pretty well. Not all the automatic stuff works well on SEMs and FIBs. Okay, and here's one thing with the stored files. For some reason, I have saved this file with 150 nanoamp for the Z, but notice it came up as 15.8. So it should take about a minute or two to get a deposition. So if you ever see deposition or a removal rate that's really, really fast, you make sure you check that Z height. And then go to an area where you did an image. Okay, so we're going to an area that has absolutely no damage on it, and we have to be at 0 degrees tilt. So a lot of little steps to remember, but it's one of those things where it's just kind of like driving a car. Once you're shown and you do it a couple of times, I mean, you get very used to it. Now, Toby's done a lot of work with the Hydra. He hasn't used the Quanta that much.
And we'll adjust our focus and our stick. And we'll warm up our platinum.
Yeah. Now, if for some reason, I know as a protection on this instrument, if you are if your working distance is well above 10, like say for some reason you're at working distance 7, the needle will not inject. That's kind of a safety thing because it knows that it's not supposed to be at 7. But plus or minus, 600 microns or so, it will still inject. So you have to be very careful. It has been rammed into the samples before. And if you notice over here, here's our application file. This is where you can actually, this has already been set, but if for some reason you wanted to change this a little bit, you can actually go ahead and enter a different dwell time. And also you can go to the advanced page and change some of the, right up here, and change some of the parameters there if you want. Then that would be overlap. And again, with the electron beam, you can elect the electron beam run over your sample. It's not a big deal, you're not damaging it. It's the ion beam that you really have to be careful with.
It says that it's warm. So I'm gonna open up the valve. So now we have flow. And then we're going to wait for our chamber pressure, which is the readout at the bottom right-hand corner. Can you see the mouse, or am I moving the mouse?
I'm moving it, right?
Oh, okay.
It's separate. Yeah. Okay, yeah.
And we're waiting for about -5 or so, which we're at.
Mm-hmm.
So then we can press the play button up at the top right, and we can start our patterning. So whenever you see anything in
so it's drifting,
green,
so you're gonna have to correct with the X and Y. So this is one little kind of quirky thing with the electron beam sometimes. Notice that the image seems to be drifting a little bit. We have to correct it sometimes with the X and Y shifts on here. So it's just one little quirky thing. It happens with some samples, not with all of them. As long as we have a tiny thin layer of platinum on the surface, we're okay. We just want to protect that region. So right now the ion beam is only going rastering over where that green square that we've made. And just like I showed, it's going to cleave off the organic part of the organometallic and just deposit the metallic part, which is platinum. And again, it's not pure platinum. It's going to be a mixture of platinum, and in this case, platinum and probably some hydrocarbons as well.
Then we can delete our pattern. And then we can see where we've deposited our platinum. Okay. So then we'll
go over to like if you're going to tilt. Okay, so we're gonna try and tilt. Now notice that the tilt and rotation are grayed out. So this is another kind of security feature. That means if you've got any needles in here, either the OmniProbe or the gas deposition, it's not gonna let you move the stage. So if you ever see that, it just means that you've forgotten to take out your needle, okay?
Yeah. And in quad 4, it removes the needle. Then if we go back to our navigation, now we can tilt. So we'll tilt back to the 52 degrees.
And now when Toby starts up the ion beam, we have this very thin layer of platinum that we've deposited on the surface. It's not going to damage whatever's underneath there. Okay. And you can see it's lined up pretty well.
Kind of see, yeah, there it goes, right there. Then I'm just shifting the ion beam a little bit. And do you have a pattern for this?
Yep.
To do another.
So now we're going to import the pattern for
and platinum IDEP.
IDEP, yep. Okay, check the Z on that one. Okay, I don't know why it did it for the other one. I don't understand that. Okay.
From 1 to 1 nanoamp.
Actually 0.5. Yeah. So the application file is platinum deposition optimized for 1 nanoamp, but it actually works better with 0.5. And we're basically going to, let's change this. This is actually works fine, but let's go ahead and change the X to 15 because we're going to, what we're going to do is in the final thinning process, we're going to make 2 windows. We're going to prepare one using the cleaning cross section and one using the rectangle section to show you that you can do it either way.
So when you change beam currents, you want to get a small window, a reduced area, which is the small box. And then we'll change the focus. And then we take a snapshot just to make sure we're actually on our spot. So notice we're a little bit off, so we just have to move our pattern down here. Then what we can do is we can reinsert our needle.
You'll see it come in down here.
And then you'll see the needle come in the bottom right-hand corner.
So go over to the electron beam and zoom out so you can see how close it is. Okay, so yeah, so you got this huge needle hovering just above your sample, so.
It's kind of freaky sometimes how big some of the stuff is comparative to the area that you're looking at.
Zoom up a little bit on there. Yep. Okay, and then what I always tell people is take a snapshot just before you start patting. Always take a snapshot just in case something's rifted. Everything looks okay. And now when we double click to open up the platinum flow, it shouldn't shut off on us like we did before. So we're looking again at the chamber pressure. There we go.
So now it's done. And then we'll remove our platinum rod and go over to the electron beam. It should be a little bit thicker, yeah.
Yeah, and that's kind of what you want to see.
And we'll delete this pattern on the I-beam. And do a fog out.
So he recalled this pattern. In order to move this pattern, you have to hit Control A so that you get all the patterns to move at the same time. And we're going to do this at 7 nanometers.
And if you notice, the higher the beam current, the more damage it can do, and the more material removal will happen a lot quicker. So I'm trying to keep the pattern away from our area of interest right now. So there's this little gap above and below. If you can see me move the pattern, I don't want it to be at the very edge of our area of interest. I need it to be kind of in between, somewhere around there. Then I'll do the reduced area thing again, unpause, and then quickly adjust contrast and brightness.
F9, it's really quick.
Yeah.
You'd be surprised at how useful it is.
Then we'll change our.
And there's a little bit of stigmation in there, so he's adjusting the stigmation.
Goes right there. Then I'll undo the reduced area, and then take another snapshot. And it drifted a little bit, so we'll adjust the pattern.
Okay, so if you take a look at the application file, we have silicon very high current because we have a very actually large overlap. Not actually, large negative overlap on here. I think actually, can you go over to advanced? Is it 0 or is it -50? Okay, it's -50. So since we have a very large beam, we can actually go with a very large negative overlap. So if we go back to the basic one, we can change that overlap if we wanted to. I know that this will work for silicon, so that's not a big deal. But this is all set. We actually have 4 patterns here. So we're doing cleaning cross-section, but we're going to run it twice on each side. The first side, and we'll update it on the electron beam, you'll see a lot of redepth. And then that second time, it will kind of clean that up and actually go fairly deep. It's 14 minutes for the whole completion. So if you guys want to take a break or whatever, that's fine, not a big deal. If we wanted to go faster, we could go to a higher current, like 15, but then I'd have to separate the pattern a little bit more from that platinum that we just deposited. And so 14 is quick enough. Let's put it that way. If we went to 15, it'd be half the time, but I'd have to separate it down further apart. So then the next step to kind of bring it in closer and get really flush with the platinum would take longer. So you're trading things off. So this works out well. So let's go over here and just take a snapshot so you can see how it's cutting. So you see how it's cutting. It's starting at one end and it's slowly advancing the beam forward. Remember from the lecture, we get higher removal rates at an edge. So what we're doing is we're actually creating this edge as we move forward, and we're getting a lot more removal than what we should. We've only set this up to go down about 1 micron, and you're actually going to see it's probably going to go down more like 6 or 7 microns. All
All
right.
right, now that it's done, we'll take another snapshot.
Okay, and you can see that it's compared to what it was before from the blue drawings. You can now see that it's a lot thinner, right? And that's what we've done. We've reduced that amount of redap. Okay, big difference. Okay, next up is the cleanup cut.
So I'm going to tilt to a little bit higher. So I'm going to do +2 degrees.
4.
Okay. Then what I'll do
Can't
is
do that on the other one because we were so close. See, this one you're far away. There's slight differences between the Quanta and the Hydra. On the Hydra, you can't. So the working distance on the Hydra is 4 millimeters. So you can't really tilt to 56 degrees over there because you might hit the pole piece. So
3.
3 nanoamps. Yeah. So now we're going to a little bit smaller current, so that our beam is going to be a little bit finer, and our beam tails are also going to be a little bit finer. So you should see a very sharp, much sharper image with the ion beam now. And this is opposite of what you'd see with the plasma fib. Oops.
When we're at slightly higher tilt, then I'm going to do the rectangle.
Nope. Now let's do a clean cross section.
Cleaning.
Yep. So set it up to X. Let's do X25. And the only reason I'm doing 25 is because we're doing a little bit larger area length, so that I can do 2 windows on there. The application is still going to be the very high current.
Oh.
Yep. Still looking very high current. Yep. Z is going to be 1. Okay, and as far, so 1, let's go ahead and hit F5. Okay. So you want to drag up, let's see, you want to drag up your top part here to be fairly flush with this edge here of the platinum, and then the backside has got to be just a little bit past this bright area, okay? So if you imagine you're looking straight down at this window, if it was still at 52 degrees, you wouldn't see this bright area because it's parallel. So what we've done is we slightly tilted it, so you're getting this bright area because we're getting more secondary electrons coming off there. And all we're gonna do is we're gonna run this pattern twice like we did before to do the cleaning again.
All right, so now that pattern's done, I'll delete that, and we'll take another snapshot. And then notice we're right at that edge of our area of interest. So now we have to clean up the top side of our sample. And what I'll do is I'll tilt from 52 -4, so it's 48 degrees. And then we can see in quad 4 that it lowers our tilt. And then what I can do is I can go back to the ion beam and then take a snapshot. And what I want to do is make another pattern. Oops, I shouldn't have deleted that. Cleaning cross section. I'm going to change it to 25 in the X. And then I'm going to change the scan direction from bottom to top to bottom, so that we start up at the top and get closer to our area. snapshot. There you go. And I'll take a snapshot of our ion beam, or our electron beam on quad 3, which is the bottom left.
So now the same thing we did on the front side, we're going to do on the back side. Now, our secondary electron detector is set up so that we can only see the front side. So that's what we always kind of do, the same thing on the back that we do on the front, because we assume that the same thing's happening on the back side as the front. Works out great for silicon, but if you have a polycrystalline metal or something like that, that assumption may not always be correct because of the orientation of the grains.
As we finish, take another snapshot, and it should be a fairly thin window. I'll go back to our ion beam, delete the pattern. Yeah.
So now we're going to go to do the J cut. So we have to be at 0 degrees so that the ion beam can kind of undercut this window.
And I'll take a snapshot on the electron beam. And now we're normal to our electron beam, and we'll be at 52 degrees comparative to our ion beam.
Take a snapshot with the ion beam. Yeah, so notice how the ion beam, the sample drifted just a little bit down. This one's not too bad. You can actually use your beam shifts to correct for that. If it's way off, you can just use your Z knob on the front of the instrument to adjust it. Do I have a J cut pattern that we can import?
Yeah.
Okay.
So then we're going to import another pattern.
You might have to change the dimension since we went to 15.
Then I'm going to select all, and then I'm just going to move the entire pattern over.
Okay, now to unselect it, this is weird. You have to go to the drawing thing and then go back to the patterning page. There you go. So now slide over, slide it over.
Then I'm just expanding our J-cut window, or our J-cut, so that it's a little bit bigger. And then there's a little bit of overlap between pattern 1, 2, and 3.
Yeah, there's actually another pattern underneath 4, so, but that's okay, it should be fine.
And then notice the placement. I'm making sure that the bottom portion of my J is on the left side of our window. And then this total process, that's all run in parallel, right? It is.
Now it says 17 minutes because the Z size is set for 6. It doesn't matter how long that Z is set for. You can set it for 10, 50, I don't care. You're not really going to pay attention to that. You're going to be monitoring the image on the electron beam, and you want to see that inverted J pattern kind of transfer to the front. So what we're going to eventually see is we should be able to see this J pattern
on the electron beam side.
on the electron beam side, and that way you know that you're cut away on the bottom and on the left-hand side and partially on the right. Okay, so that's what we're going to look for. And so if you come over here to the ion beam, adjust your contrast a little bit so you can actually see the beam. Yeah, so we're actually seeing the beam live on the ion beam here. It's only on the patterns where we have it, where the yellow patterns are. And we can monitor this live, and we can see probably what we're going to see first is these little holes come in on the bottom side here, because we've got an overlap with the patterns.
Yeah, there you go.
Mm-hmm.
So in the bottom left-hand quadrant, you can start seeing our pattern show up. And we're cutting the left side of our window, and then you can see part of our hog out area where the J-cut is going to appear.
Mm-hmm. Okay, you can kind of see that we've just got a little hole in the upper left-hand corner where this J is. So if I go ahead and refresh, I'll refresh up here. It's kind of hard to see, but we do have a little bit of a hole forming right over here. And now you're seeing that hole expand. We're also getting a hole on the right-hand side as well. But notice there's still some material connecting on the left-hand side. So we have to make sure. So now we can kind of see here, we have a line across the bottom. We've cut away from the bottom. And that's very important, because the last thing you want is to attach your needle and still be attached at the bottom. But notice how you now see this pattern coming in here. We still have to wait and go through a little bit, because we have to make sure that we're cut away on the left-hand side. So that's why I say don't worry about the time. Just make the time long enough that you know that it's going to cut away. So 10, 15 minutes, it doesn't matter. We're just going to monitor until we've got everything cut away.
Oh, you can even see it cutting through at the bottom already of our window. So there's this really small sliver that's a little bit darker in quad 1 comparative to quad 2. And that's where we're cutting through our area.
Yeah, and so you can tell that we haven't cut through on the left-hand side, because you can see that this material here, it has not been touched, still intact. So let's take a snapshot. Okay, it's getting smaller and smaller, but it still hasn't been touched.
On the left, or I mean on the right side, you can see the other part of our J starting to show up.
It's hard to draw straight.
It's hard to draw straight on the mouse, right?
Yeah. So that is the part of our J. It still has not connected. So this is all the cut area. So we still have that just tiny little membrane there that needs to be cut away on the left-hand side.
So we're cutting the bottom of our window out, as well as part of the right side, and then all of the left side.
Extension. Okay, and there we go. So now let's go ahead and stop.
Oh, you're not.
The one thing,
It's
where?
barely there. There's a little bit.
No, there's nothing there. I can tell there's
Yeah.
nothing there. So, okay, so here's another thing. There's two things here I want to show you. One, see what's happening here? You're getting what I call fangs, okay? And sometimes if you're not cut deep enough, or if you do this J-cut long enough, sometimes those will reattach on the front side. That's actually redep. Now there's a question here whether this is attached, whether we've cut all the way through or not. Just to make certain, let's go to 30 degrees tilt with the go ahead and unpause the electron beam, and let's go to a 30 degrees tilt. Oh, you have to stop the patterning, otherwise it won't let you move. And then let's go to 30 degrees just to be sure.
Oh, there it goes. And you can see that you're no longer attached at the bottom.
Okay, so it's very, very clear. We're not attached on the left-hand side. We've got a clear detachment from the bottom, and a little bit of a detachment or a little notch on the right-hand side. So if for some reason you're not 100% sure if you're detached or not, just go ahead and tilt up to like 25, 30 or something like that, and just make absolutely sure. Okay. All right, so let's go back to 0. All right, we can clear that. And now the next thing is to insert our needles and attach it to the window. Now, the first thing you're going to do is you're going to, well, first you're going to take the Z knob and go count. So we're going to take the Z knob and we're going to turn the knob half a turn counterclockwise. So that's going to move us away from the eccentric position. And the whole reason is that now we're going to insert our OmniProbe needle, our lift-out needle, and we're going to put it at the eccentric position. But if we left our sample at that height, it would just kind of cue it right out of there. Yeah, that's a good idea. Zoom out so you can see the needles come in. So this is the gas injection needle.
On the right.
Now, what you didn't see is, Toby, the OmniProbe is controlled by another computer that's over here. The first thing he checked was that it's in the park position. You're gonna bring in the needle and take it out in the park position, but you have to make sure before you put it in that the last person that used it made sure that they put it in the park position. Otherwise, it's gonna go straight into your sample. So now he's gonna insert it, and you're gonna see it far off on the left-hand side. There you go. Comes in pretty quick.
So the needle that we just inserted is on the left side.
Okay, so that's considered the park position, far enough away. Now he's going to move it to eccentric position, which in this case is called 0.1. Let's zoom up the magnification. So so that's why we move our sample away from the eccentric, because right now the needle is going to that eccentric position. It's a little bit fat. It's a new needle. Okay. Okay. And so now what's going to happen is we want to move the needle using the controls on the OmniProbe to move it right about here. So it just overlaps with the sample or window. You can see there's a little bit of platinum still stuck on the needle, but that's good. If you have to, sometimes if there's an excessive amount, you sometimes have to clean it off. That looks good. All right. So now we're aligned top down with our electron beam. So now we have to bring up our sample to where the needle is. The only way to do that is using our ion beam. So we're going to switch to our imaging current, which is a very light current. We're going to move the needle down a little bit with the OmniProbe controls. We're going to Z down. Yep. So we want it to be right at that kind of crosshair. Okay, and then we're going to raise up our sample with the Z control on the Z knob on the front of the instrument. So we're rotating the knob clockwise. And you're going to stop just before you hit. Okay, let's stop there. So we're going to stop here, and then we're just going to check to make sure with the electron beam, see how it moved off a little bit. So we're going to reset that needle just a little bit. It's going to hit right on the corner now, right? Now we're going to go up and touch, and you're either going to see a series of horizontal lines, or you're going to see kind of like a change in contrast. There you go. So now you know you've touched. So now we're going to pause, and we're going to deposit a little bit of platinum to connect it. All right. So now we're going to change our current to 0.5 nanoamps for deposition. And we're going to deposit a little rectangle of platinum. At least it'll clean it off, right?
Yeah,
Okay. So let's change application to platinum. Optimize 1. Okay. And we want, so that's good. We want about a 1 minute deposition time. So you can change the length of the platinum, but see how it's on the needle as well as the window, and it has to be. So we're going to go ahead and open up the flow, waiting for the pressure to get higher. Okay, let's take a snapshot. Good deposition. It looks like we're attached. So now let's delete that. And now we're going to do reduced area. And we're just going to make it a thin little sliver and just kind of cut away on that little edge there. Okay. Then unpause. Or you can change. You can change that. Yeah, you can up the current if you want. Go ahead and change it to 1 or something. Okay, yeah, and it's cut away. All right, so we're done. So now we're going to image with the electron beam. And we're going to go counterclockwise with the Z knob. So just reach over, go counterclockwise, and we should be far enough away. There you go. So what we're doing is we're dropping the sample. The needle is staying still. So now we're going to move over to our grid, which is inserted in here. So we're going to move our needle position to the eccentric high. So basically this is a high point. It's higher than the needle, the gas injection needle. And that's just to make sure we don't bump it. So while our two needles are in, we're going to move over to the grid, because the grid is sitting below our sample. Our sample is nice and flat, so we can just kind of move over. So if you want to zoom out. Yeah, there it is.
There it is.
There you go. Hit F5. So here's the thing, our grid is not 100% horizontal. Normally we would use our XT align feature that you see at the top here, but it's grayed out. Again, we have needles in, the system knows it, it's not gonna do anything automatic. So you're gonna take the rotation knob on the front of the chamber, and we're going to rotate it around until it's nice and flat. I kind of prefer it like this. I like doing the manual stuff. That looks good. Toby's a perfectionist. Okay.
I don't know, maybe.
Double click to get that one. Yeah. Okay, so we're going to put this on one of the prongs. Okay. So now we're going to just go. Okay, so now we're going to lift it. So now we're going to go to the ion beam. Because again, with the electron beam, we're top down, so we really can't gauge our distance. And we're really far away. One, you can't see the sample in here because we have lifted it above the needle. You can crank it. It's really far away. So he's going fairly fast. What you're gonna see is this is the stage that you're seeing down here. You're gonna see a little bit of a scoop come up, and that scoop right there. So hold on one second. Yeah, and I'll take this little scoop right here. Is part of the stage, and that's telling you that you're going to be really close to your grid coming up. So, and that's where it is, right there. Okay. So that's the way to tell. So the very first thing we got to do is, if you notice, there's a lot of this dark material on the surface here. There's a lot of crud and stuff. A lot of hydrocarbons. These grids are just kind of lying around on the, they're in a little enclosed cap, but it still gets some hydrocarbons on it. Let me get this. So we're gonna clean off that surface first with a heavy iron beam.
We'll take a snapshot. Oops. Adjust the contrast and the brightness, pause it, and I'll do a reduced area again, and then that way it's just a little bit quicker. Then we're going to clean off our entire grid. And then you do it for maybe 10-15 seconds or so, and you'll see it change. So after we clean off the grid, Now we're ready to create a small little notch. And we want the little notch so that we can put our fib sample into this little notch. And if you remember, our fib sample is a rectangle. So we're going to cut out a little rectangle that's a little bit bigger than the area that we cut out in the first place. So we will do a rectangle, and I would like to make a little rectangle. And then we'll make our X maybe 25 micron. And then we'll make our Y a little bit smaller. Like so. And then we'll change our Z to about 3 micron. So our time is about 5 minutes or so. And this is so that we can have a little landing pad on our fib grid to land our sample on.
Yeah, and that's what you want to see, a nice, clean, flat notch right there. All right. So that's what we're looking for, okay? So we can stop there. Oops. Definitely go back to your imaging current so that when you stick in your sample, you don't burn it up. Because 30 nanoamps is a lot of beam. And you just want to back off. This is using the Z knob again on the front of the thing. You just want to back off your Z knob till the top of your prong is at that position, just to make absolutely sure when you stick in the OmniProbe needle, go back to the eccentric position, that you're not going to smack into the prong and knock it off. Okay, so now let's go back to the electron beam. And then zoom up. And now the thing is, let's go back to our beam page. Are we at you descent? Set your beam shift to 0. Okay, so now you're going to double click on this notch to get it into the center. And you don't have to worry about hitting your sample because it's far enough away. And now, zoom up a little bit more. We're going to use the X and Y alignments on the OmniProbe program to center this little sample right into that notch. Right, and that looks good for now. So now we're gonna go over to the ion beam. Right, hit Control F to focus. Unpause. Control F. See, gives you a sharp focus. So now you're going to raise up the grid with the Z knob. And again, just before you touch, we're gonna take a look at the electron beam. Keep going. All right, let's stop there. Now let's go to the electron beam because things probably shifted a little bit. Zoom up in magnification. Yeah. Yeah, so the Y kind of drifted a little bit. Down. That looks pretty good right there. Okay. So just like we did before, when we actually touch, we're going to see either a change in contrast or a bunch of horizontal lines. There you go. All right. And so now we're going to set up to do our depositions. So let's pause. And then we're going to deposit using a 1 nanoamp beam.
Wow.
Looks pretty good, yeah.
I was not expecting that. Okay.
And that one, oh, so you want to, so here's a little trick. You want to not be in parallel mode because it screws things up. So take out of parallel mode. We're going to change that to deposition. And we're going to go, Z is going to be 2. All right, and then you're going to do another one on the other side. And make that a little bit longer, yeah. Make the number 2 one just a little bit longer, just to make sure that you get good. Yeah, a little bit more. Yep, and then widen it out just a little bit. I just want to make sure that you're getting onto the, okay, so this is going to be about, what, 3 minutes or so?
Yep.
So now we switch it to parallel. Okay, and on this system that works the best. If we tried to do it in parallel, it would give us something very goofy. So now, Toby, double click to open up the flow. We're waiting for this to be, to go up to the 5 range.
Snapshot. So now we can see that our sample is secure. Now we're ready to remove these 2 patterns on the ion beam side, and then add in a cutting pattern.
You know what? We're not connected still. Here, see, this is not connected.
No.
So one of the, oh, you got that? Okay, perfect. Yes. So here's what I was looking at before. Oh, okay. But yeah, you want to make sure that you have this connection right here. Okay, you can't have a gap there. If you have a gap there, then it's not going to connect it. You take a snapshot. Ooh, not 30 nanometers. It was still at 1 nanoamp, wasn't it?
Yeah. Is that 1? Cut it away at 1?
Yeah. Take a snapshot. Okay, so yeah, we're just gonna leave it at 1 nanoamp and cut it away at 1. And this, hit F5. The one thing you want to do is you want to make sure that you cut where the, right along there, right, where the deposition is. And you can make this about half that thickness. Yeah, all right, that's all you really need. You don't want to cut away the tungsten needle, one, because the tungsten is going to be a lot harder to remove than the deposited platinum. And two, I don't want to keep having to sharpen and replace this tungsten needle. Okay, so all we're waiting for now is for that to cut through. And it should go fairly quick.
Okay.
That should be done.
Yeah, that should be it.
Yeah, okay, that's definitely cut away. So now you're gonna go to the electron beam, unpause, and the first thing you're gonna do is just rotate your sample counterclockwise, move it away from the needle, just a couple of turns. And then you can move your needle to the park position. And then we're going to take out our platinum needle and we can turn it to cold because we're not going to deposit anymore. We're done. Okay, you can take that out now. And we have to wait for our needle to get to the park position before we extract it.
Now we can see that our sample is actually secure to our grid.
So now the next thing to do is we're going to go ahead and start the thinning process. So we're going to raise up our sample. And now we're going to tilt to 52 degrees. And as it's tilting, we can go ahead and adjust the Z if we're a little bit off on our eccentric. Okay, so see, it looks like it's dipping down a little bit. So go grab the Z knob and then just bring it up. And so a couple of things we're going to do here now. So one, we're actually going to tilt a total of 3 degrees. Like I said, this is a little bit older instrument, so I'm not sure if it can handle a half a degree shift. So we're not going to do 1.5 and 1.5. We're going to do plus 1 degree. So we're going to go to 53 degrees. Okay. And then when we do the opposite side, we're going to do negative 2 degrees. But the other thing is we're going to change our voltage on the electron beam to 15 kV. See if it'll work. Let's try 0.4. It might not be aligned. It's not aligned. Oh yeah, it is. All right, okay, perfect. Okay, it gives us a little bit more. So what we're gonna do is we're gonna use the fact that as we thin this down, the silicon is gonna become transparent, right around a little bit lower than 1 micron. And now we're going to go to our ion beam, and we'll start off with 1 nanoamp. And let's take a snapshot. Okay, so double click to get that into the center. And let's take a snapshot. All right, perfect. So now let's zoom up a little bit more and use our Y shift to bring that down a little bit. Okay. So what we're gonna do is we're going to do 2 windows in here, and we're gonna do it by 2 different methods. So the first one's going to be the rectangle. So we're gonna make a rectangular window, and we're going to click and drag out the window, and we want it to be 4 microns. Let's make it 4 microns, just make sure. We want the application to be silicon. We want the Z is going to be 1. And then we're going to go to advanced section. And we want to make the overlap, well, let's make it 95% first. And it may tell us that it's too many points. But let's pause here on the electron beam and go to the ion beam and hit F5. So what you want to do is you want to do this a little bit slowly at a time. So we're going to take and we're going to move the bright edge to just about there. And then we don't have to be that far back. We just have to bring that up until that really bright edge right there. Okay, so that's going to take 29 seconds. That's a whopping 29 seconds, okay? So let's go ahead and run that. All right, so it was okay with, so now if we want, let's go to hit F5. And we can kind of monitor that with the electron beam, take a snapshot. So now we're cutting into the material. Notice we set it to go 1 micron, and it's actually what, probably 5 or 6 microns deep.
Yeah.
Okay, and that looks pretty good. Okay, so now what we're going to do is we're going to go to cleaning, delete this one, and we're going to do cleaning cross section. Let's make this one 5 microns, and that way we can tell the difference between the 2. Okay. And for the Z, we're going to keep the Z at 1. Advanced, same thing, we're going to go to 95%. Okay, and that looks good right about there. We want about the same distance, okay? So same thing, maybe bring this back just a little bit. All right, okay, yeah, that looks good. 1 minute, okay, let's run that. So now the big difference you're gonna see, go ahead and hit F5, is that it's going to slowly creep into this sample here. So see, we're hitting the outside here. We're not even hitting the edge really much yet. So if you go to the graphs thing right here, what you're seeing, this is the absorbed current. And as that gets closer and closer, this graph is going to go up. So we're getting more specimen current. Okay, so that's how you can kind of monitor to see how close you're getting to the edge of your sample. And whenever we take a snapshot, it's going to drop down, okay? And I show you these 2 methods because these are the 2 methods that people use. Okay, you're not seeing that much of a difference here, not a big deal. So now we're going to go to the other side. So we're going to go -2. So we're going to go to 50. And all we need to do for the ion for this one is just flip the, go from top to bottom. Well, let's zoom up the magnification a little bit. Yeah. Same thing. So I know it's thick, but we're just going to do this a little bit at a time. Let's move that back just a little bit. So it's always better to be cautious. We spent a lot of time making this sample. We're getting close to the end, so we want to go ahead and just be cautious. Same thing, we're just going to go ahead and run this. And what we're going to do is we're going to monitor the electron beam. When we see a change in contrast, as we move this in closer and closer, we're going to take a snapshot, and we're looking to see when we see a contrast change right into the center of this sample here, right? And that'll happen right about 1 micron or so. Now, a lot of people, what they'll do is they'll actually come over to the ion beam and they'll take a measurement. There's a measurement tool that you can use to measure across here. That takes a lot of time because you have to stop, you have to draw, measure, and check. What we're going to do is we're going to just basically do it visually.
You can even see the dip on the backside too.
Yeah. There's a little bit of a contrast change, but we want to see a really bright difference. Okay, so now instead of moving the sample, we're going to go to the Advanced tab and see where the position 3.4 microns is for the Y. We're just going to subtract 300 nanometers. Okay, so that should be 0.04. So we've moved it in 300 nanometers. We probably can move it in a little bit closer. Let's go, yeah, let's make it minus 0.2. Probably even more, minus 0.4. All right, that looks good. So we're going to run that. And again, let's take snapshots with the electron beam. Okay, looking good. All right, let's take a snapshot. Okay, so that's the contrast change that we're looking for. All right, so now we're thin enough there. We're going to delete that pattern, and now we're going to do our rectangular section. Same thing, we're going to do the rectangle, 4 microns. Now, I know the beam is symmetric, but as we should go top to bottom. Same as before, yep. And we want to change the overlap to 90% again, 95% again. And take a snapshot. Looks good. Let's run. And then the same thing, we're looking for that contrast change. Now, if you look at the graph, this is going to be a little bit opposite of what we were seeing before. What's going to end up happening is that the absorbed current should actually go down because we're removing material. You can see it's removing fairly quickly. Okay, we'll take a snapshot with the ion beam, and then we're going to move it down another 300 nanometers or so. A little bit more. Let's make it, what did we have before? Minus
0.4. Seems like a lot.
Let's try it. Yeah, that looks good. And you're gonna see over here, this bright area, it's eventually gonna get dark because we're gonna remove it all. See, you're starting to see it. So let's take a snapshot over with the electron beam. Yep.
Yeah.
So see, we're starting to get that. So right now, both these sections are on the order of less than 1 nanometer. I'm sorry, 1 micron. Okay, so now we're going to go to our next current, which is going to be a smaller current and our last current. It can be, let's see, it could be 0.5 or 0.3. At this point, we're not really removing a lot of material, so we're going to focus and stigmate. So yeah, so I never change it at beam. It's always going to be a little bit of stigmation. So let's try and get that a little bit better. Make the reduced area a little bit larger. Yeah, go ahead. This one has to be right on the money. Very good, very good. Okay, that's a good. All right, take a snapshot. Adjust your contrast a little bit. Yeah, take a snapshot. Okay, so now same thing. Let's zoom up in magnification a little bit. There we go. Take a snapshot. All right, so now you got to move that edge again right up close. Yeah. Now what we're gonna do is with the electron beam, we're gonna change that to 5 kV. So now you're gonna see the contrast change back to dark. And now we're going to, again, wait for this to change to be brighter. Once it starts seeing a little bit of contrast change here. And this one may not work. This was not aligned. Yeah, 53 I know works. Okay, and use your shifts to get that up. Let's focus and stigmate. So now again, our contrast is dark because the 5 kV beam is not penetrating through those little membranes. So once we start to see some penetration and a change in contrast, we're going to, we'll know that it's about less than, in the range of 100 nanometers or so. Okay, let's take a snapshot again with the ion beam. Make sure everything looks good. Shift it a little bit, that's good. And overlap is still 95. Yep, that's what we want. Only 40 seconds, let's go. And what we're gonna do is we're gonna run this at least 1 time on the back side, 2 if we want to, but then we also have to run it on the front side. So again, you're seeing this get darker, so basically we're just milling away that material. Okay, let's take a snapshot. Okay, so it's fairly thin. We can move it down. Now I would say just move it about 100 nanometers. So minus 0.6, yep. And then move this back part. We don't have to move all that. So we're just going to make a very thin, yep. So it's gonna be even quicker. 18 seconds, there you go. So we've just kind of like, we're now shaving off about another 100 nanometers. So we've run this twice on this side. Now we'll go to the cleaning cross section on the other section and do the same thing. Now the Z, we're gonna change to 0.4. Okay, and top to bottom. Okay. And then we're at 95% overlap. All right. Go ahead and start. A little bit of time is fine. Only 26 seconds. So you can see this is going pretty quickly. Again, we're doing two windows here. You guys would only be doing one, so we actually go a lot quicker. Okay. Let's move it down about another 100 nanometers and yep. Okay, that's just right. Okay, looks good. So now we're going to flip back to the front side. So we're going to go back to 53 degrees. And then we're going to go bottom to top on the thinning cross section. So you notice that big shift there. This stage is kind of old, and so it drifts quite a bit. Okay, move it up just a little bit more. Okay, so now, and move this back. See this little line right there? Move that right up to that line. Yeah, okay. 29 seconds, let's go. And what we're gonna do is we're gonna monitor this graph at the bottom here. So we know it's already starting away. It's gonna dip down, and as we get closer, it's going to go higher. Okay, so now it's hitting the front edge. Okay, let's take a snapshot. So a couple of things we're seeing here. One, let's see, where's my thing again? There we go. Okay, so this very thin line here that you see, this dark line, that's our electron beam deposited platinum. Okay, so it's going to be lighter than the ion beam platinum. Underneath that is a very bright line, which I believe that's the coating. And then we also have this other area underneath here that has this kind of like wide band. That's another coating that's on the surface here. I don't know if it's SiO2 or not, but basically we're seeing these layers, okay? So now, same thing, let's go a little bit at a time, 100 nanometers at a time. There we go. Take a snapshot. Okay, and bring the back up to about there. We don't have to go that far back. Okay, and then go ahead and start. That's a little bit too, yeah, right about that. Yeah.
This cut's a lot cleaner.
Yeah, it just depends. Take a snapshot. Okay, and let's move it up. Take a snapshot with the ion beam. Okay, and move it up another 100. Let's move up a little bit more. I think we were far away before, so let's move up another 100. Yeah, go ahead and do that. And what we're gonna do, see it's taking 16 seconds. So like every 3 seconds, let's take a snapshot with the electron beam.
Oh, yeah, there it goes.
Okay, so try and get a little bit brighter, and notice that it's very bright at the top, but not at the bottom. So what we're creating is this tiny window, another 100 nanometers, just at the very top. So what we're gonna monitor now is basically how thick our platinum is, okay? Same thing, we're gonna move it up 100, and now we're gonna take a snapshot every 2 seconds. And we're also gonna monitor our graph, because once this platinum gets to about this level, we're gonna go ahead and stop. Okay, very bright. So we still got plenty of platinum. So now let's take a snapshot with the ion beam. Now let's move it in only, let's do 50 nanometers. Oh, I'm sorry, 50, yeah, 50 nanometers. Yeah. Okay, so again, now what we're gonna be doing, same thing, 2 seconds. A lot of the polishing or a lot of the thinning that we're doing is actually going to be just our beam tails. Ooh, let's stop. Let's go ahead and stop the patterning. One thing I have to worry about is if you see this on the side, it looks like it's actually cutting away from the left-hand side. So let's go ahead and shrink this up about 4.5. Let's make it 4.5 microns.
Oh, let's stop it.
Yep. Okay. All right.
Okay.
Just run it. And every 2 seconds. Mm-hmm. Okay, let's do another 50. Okay. Ooh, it looks like it's almost cutting there a little bit too much. We could probably cut that back down to 4 microns. And let's go to the advanced section and move that position for the X. Let's move that to the right a little bit. So make it 2.89. Yeah, there we go.
Yeah.
Okay. And move that up another 0.5. So now we're going to take a snapshot every second. Okay, so we want to go very slowly with this one. And as soon as we see that, make sure you get ready to stop. Okay, it's going down. I would stop it right there. I mean, that gives it. So here's what I tell most people. So that's perfect, actually. We've got enough ion. Stop. So we still had a little bit of platinum on there. So now we're going to go to the other side. We're going to do the rectangle section. Now this one, we can keep this one at 1 micron. It doesn't matter, or 0.6 microns. The reason we can make Z 0.6 is that we're at an edge. So we have enhanced milling. So even though we're saying 0.6, we're still gonna go fairly deep. So 18 seconds, and move that up just a little bit. That looks good. All right, let's start. And again, like every 3 seconds, let's take a snapshot. Okay, so we're seeing a contrast change. We're getting thinner. Now, same thing. Oh, someone's got a question in the chat. Keep going. Okay, so 5 kV or 2 kV for the final polishing. You could go either way. Definitely 2 kV is going to give you a better final polish. It's going to remove a lot more material. I'm sorry, it's going to reduce that amorphous layer much more. But as we'll show, it's going to be very hard to focus and stigmate the beam at 2 kV. So some people prefer to do it at 5 kV. Either way, at least as long as you remove or reduce that amorphous region, you're doing okay. What are you gonna do, 100 or 50?
50.
Let's do 50. Now bring the back up a little bit if you want. "17 seconds. Who shaved off a second? Yeah, so now every 2 seconds, take a snapshot. Okay, so what we're monitoring is not only the thickness or the transparency here, is the thickness of this platinum. Okay, once we get rid of that platinum, we have to stop. Otherwise, we're just damaging our top layer. Don't worry about the back there. We're not concerned. Remember, all the information that we care about is right up here in this top layer. Okay, so that's where we're going to be imaging. Anything that happens down here doesn't matter. Yeah. And now every second you're going to take a snapshot and just be ready to stop her. Ooh, nice. Very cool. You can stop it there because I'll tell you, that's pretty thin. So I always tell people, err on the side of caution. You could always remove more. If for some reason you take this to the TEM, so like say this left-hand side here, you take it to the TEM and it's still a little bit too thick, you just bring it back to the FIB and you're just going to polish it off with the 2 kV for a couple of seconds, and that should take care of it. Okay, so now we're going to go to the final polish. So what we're going to do is, let's go to the beam page. And you want to, oh, I'm sorry, it's this. stage page. I don't know why they put it here. Uncouple our magnification, okay, because we want to keep our magnification on the electron beam fairly high. We're going to go to 2 kV on the ion beam, and we want to go to 83 picoamps on the ion. And then we're going to tilt plus 4 degrees, so we're going to go to 56. Okay, so we're going to show you what polishing looks like at 2 kV. So you can unpause the beam, it doesn't matter. We're going to be, so zoom out, you know, you're going to have to zoom out, and then hit F9. Yeah, so don't worry about damaging the sample at this point. It's only a 2 kV beam. So let's zoom up a little bit so we can kind of see where our features are. Right about there. You don't even bother putting it back into the center there. So you can see how difficult it is to get a good sharp focus here, okay? And there's some stigmation, but it's not a big deal. We're not trying to thin the material. We're just trying to remove damage. So let's go ahead and pause. So let's go to our patterning page, and let's hit the down arrow here and select our pattern and set this to be, go to basic and set it to be like 20 by 20. Okay, so then just drag that over to where that should be. Yep, and let's tighten that up a little bit with the Y. Yep. And all you're gonna do is just run this for 30 seconds, okay? So total time is 3 hours, 32 minutes, 37 seconds. We're just gonna run it for 30 seconds, okay? And if you want, you can monitor the electron beam, but all we're gonna do is just 30 seconds on either side, and that should remove a lot of the damage. Okay, now we're gonna rotate to the, or tilt to the other side.
50?
48. Quick snapshot. Yep, it's right over the area, and just run it again for another 30 seconds. I don't know why it does that. Yeah, exactly. We didn't change anything. We just tilted the sample and changed the value.
Okay.
That's why I want to move.
Yeah.
Quirky, very quirky. How does tilting change a...
Let's change time.
Yeah, exactly. We're in a different dimension. Okay, so let's go ahead to our electron beam. You're probably not going to see much of a change, okay? But now the final check is to change your voltage to 30 kV. F9. Yeah. There you go. And use your Y shift to bring it down. Okay. And hit F5. Okay. And let's take a good snap. Let's take a nice slow scan. Okay. So what you're going to see here, see this kind of like this, you got this very thin area up here, and you see this back here, all this back here, you're actually imaging the back of the grid. So electrons are going through this, bouncing right back and going to the secondary electron detector. So if that's thin enough to do with a 30 kV beam, you should be good enough at 200 kV, which is what you normally image at, right?
On the TEM, yep.
On the TEM. So that's how you tell to make sure that you've got a really nice sample, and it should be good in the TEM. Again, if it's too thick, you just bring it back in and do that 2 kV polish for, you know, a couple of, not even a minute or so, and that should be fine. And that's pretty much it.